Hi, in this video, this is the third video of the series. We're going to be working on a few other bank account problems and some outside problems that still work with exponential equations, okay? So the big deal on this one is this phrase right here. Whenever you see this phrase, compounded continuously, okay, that means that n is equal to infinity. And if you watch the first video of the series, that means we're continuously adding interest to your account. And that means that this formula that we have here doesn't work anymore because we're dividing by infinity and then we're raising something into the infinity power. I mean, what the heck do we do there? There's not an infinity button on my calculator. So that's when we have to switch down and we have to use this new formula, PERT, like PERT plus, right? Shampoo, if you ever forget. A is equal to PE to the RT. Notice the only thing being raised to the power is the E, okay? So what we're going to do in this problem is we know that our formula that we need to use is A is equal to PE raised to the RT, not NT, but RT. I am investing $5,000, so there's my principal again, right? $5,000. I'm going to have an interest rate of 1.25%, so be careful. The interest rate is 1.25%, but if I want to put that in decimal form, I have to move this over two places, so it's 0.0125. Okay, remember that you can always take 1.25 and you can always divide it by 100 to get that decimal for you, 0.0125, right? So it's going to be times e to the 0.0125 times the amount of years, the number of years that I leave it, which is, in this case, 10. Okay, so let's go through and let's figure out what this simplifies to. I have 0.0125. I'm going to take it times 10. There's my power, okay? So this is A is equal to 5,000 times e to the 0.125 power. I never round, absolutely never round here, okay? I'm going to do second, and I'm going to find e to the power, which is right here above ln, okay? So it says e to what power, and I'm going to hit second again, and I'm going to go down here above the negative sign. It says answer, e to the power of the previous answer, which is 0.125. Oh, sorry, my light just went off. Just a second. Come on. There we go. All right. E raised to the power of the previous answer. That's 1.33. So A is equal to 5,000 times now 1.133, so on and so forth. Okay, lots of decimals there. Oh, I moved my paper down, okay? Remember, only the E is being raised to the power, not the 5,000. So now, after we've done that, we multiply it by 5,000. And my answer is $5,665.74 because it's 0.742, so I keep it at 0.74. All right, we didn't get rich. Congratulations, after a period of 10 years, you made a whopping $600. Okay, if I would have gotten $2 quadrillion, hey, there's an issue there. I did something wrong. Last problem, okay, this isn't a bank account problem, but it's still an exponential problem because you can see I have a variable up here in the exponent. A radioactive substance decays in such a way that the amount of mass of the substance remaining after t days is given by the function m of t. The mass at any given time is found by 50e to the negative 0.075t, okay? I want you to understand that this looks a heck of a lot like PE to the RT, right? Doesn't it? Okay. The only difference is 50 must be the principal. That must be the starting amount. E means it's continuously decaying. It doesn't decay like once every 2 seconds or once every day. It continues to decay all the time. R is a negative number, which means we must be going down. Okay, it's a decay problem. Instead of bank account growing, the bank account is decreasing, and T is in days. Okay, so we're okay here. T is going to be T days. That's fine. We don't have to do anything to divide it by 365 or something to get it up to years. It's saying T is supposed to be in days in this formula. So what is the starting mass of the sample? Well, if we're good, we'll understand it's going to be 50. But starting mass also means we could put in a time period of 0. 0 time has passed by. And so what is the amount after 0 days have gone by? That would be 50 times e raised to the negative 0.0075 times 0 for time, right? 0 times anything is 0. So this simplifies to A is equal to 50 times E raised to the 0 power. Anything raised to the 0 power, I don't care what number it is, even if it's pi or E or something funky, that's just a 1, right? So it's really A is equal to 50 times 1. Oh, the answer, dang it, you know what? We knew all along. It's going to be 50, and then the units it says here are kilograms. We had 50 kilograms to start. So if you're good, you'll figure out that it's this number, the principal, right? But if all else fails, plug in a 0 for time and see what happens. The second question just says, how much remains after 60 days? That means that T is now going to be a 60, right? So A is equal to 50 times E to the negative 0.0075 times 60. The only thing being raised to the power is the E. So on my calculator, I'm going to go negative 0.0075 times 60. Okay, so I have 50 times E to the negative 0.45. I do not round that number, okay? If that was messy, I was going to keep it. I'm going to say second E raised to the power of the second negative sign, previous answer. E raised to the power of the previous answer gives me this. So now I have A is equal to 50 times 0.637, so on and so forth. I'm not going to round that number. I'm just going to take it times in my calculator, 50. I have 31.88, and that said kilograms remaining. So hopefully that makes sense. That's a pretty typical problem. You can ignore the challenge problem if I forgot to take that off your notes before I hand it out, because that involves, that's much more difficult. We'll do that later on in the unit, okay? That should get you going. Be able to plug and chug, understand that only E is raised to the power in these formulas here. Only understand, please, that only the thing here inside the parentheses is being raised to an exponent over here. And then the biggest catch though, honestly guys, convert those percentages to decimal points before you get going.